Introduction to fractions. A fraction is also called a rational number. A rational number is a number that can be written in the fraction form of a over b, where a is a whole number and b is a whole number that is not zero. Right now, the definition of a rational number is a little bit restricted because we're not in an algebra class at this moment. This is an arithmetic video, so we're not talking about negative numbers. But later on, when we are talking about negative numbers, then the definition of a rational number will be expanded to include negative numbers. But for right now, we're just talking about whole numbers, and the only number that cannot be zero is the denominator. So that's the only restriction we have, that the denominator cannot be zero. And we'll talk a little bit more about that. Okay. The top number of the fraction is called the numerator, and the bottom number is called the denominator. Here are some examples of fractions. Again, the top number is called the numerator, and the bottom number is called the denominator. How to say it. So we always want to be able to communicate, but we need to know how to read that fraction. One way of reading it is you can always read it as the numerator over denominator. So this first fraction can be read as 5 over 6. This second fraction, 33 over 49. And the last fraction, 1 over 15. A little English here. How to verbalize and write fractions grammatically correct. Okay, this is not too big of a deal here, but we're going to try to say it properly and write it properly. A hyphen is used to separate the numerator and denominator. So we use a hyphen to separate numerator and denominator. However, if the numerator or denominator is already hyphenated, then a hyphen is not used to separate the numerator and denominator. So we're saying that's just too many hyphens, right? So we use a hyphen to separate numerator and denominator, except when we're already using a hyphen. And also the following suffixes are used on words representing the denominators: th, st, nd, and rd. We'll see some examples in just a moment. The denominators will be changed to an ordinal form of the number. So here's some examples of ordinal form. Tenth. Tenth is the ordinal form of 10. Third is the ordinal form of 3. And 21st, see that number has a hyphen? 21st is the ordinal form of 21. Usually we'll put an S at the end of most of those. Like tenth, if we're saying 1/10, we won't use an S at the end of it. But if it's 3/10, see, then we have to add an S at the end of that too. So it depends if it's plural. Tenth, 1/10, or 3/10. For third, 1/3, no S. 2/3, S. Okay, let's go to the next page. So here are some examples of writing or verbalizing fractions grammatically correct. 2 over 3 is written or verbalized as 2/3. Note the hyphen between the 2 and the thirds. Again, we need that S because it's plural, 2/3. 7/16, that would be 7/16. 9/25, 9/25. Note that there is no hyphen between the numerator and denominator because the denominator already contains a hyphen. But in the first two examples above, there's no hyphen for the denominator, so we separate the numerator and denominator by a hyphen. Okay, is this important? It's important if we're writing it out in a paper. It's not a hugely important topic, but I just wanted to go over it with you. Okay, fractions used to indicate equal parts of a whole. So, for example, 3/8. 3/8 implies that if the whole were divided into 8 equal parts, that 3/8 would comprise of 3 of the 8 parts. So you can see that box there to the right, and it's separated into 8 separate squares. So that's our 8 equal parts. Note how many are shaded. 3, and that's your top number. So the top number of the fraction is representative of the portion to be described. So the portion described is the top number. And the bottom number is representative of the number of divisions, sections, or portions in which the whole has been divided, or total. So top number, portion being expressed. The bottom number, the denominator, is the number of sections the whole has been partitioned. Okay, writing a fraction from a sentence, and we'll keep that in mind that the top number is the portion being expressed. And the denominator, that's our total number of parts, total number of whatever we're talking about, people, cars, buildings. Okay, write the desired fraction. 4 out of 5 students have a cell phone. What fraction of the students have a cell phone? So the fraction they want are the students that have a cell phone. So the total would be the 5 students, and the top number, the numerator, would be the ones that have a cell phone, which would be 4. So our fraction is 4/5. Okay, so we're just making that 4 and 5 into a fraction. Next one's a little bit trickier. 7 out of 10 residents voted in favor of a proposition. So 7 voted in favor out of 10. So this is like a small sample. You sampled 10 people, and you said, hey, what did you vote for? Did you vote in favor or against? And 7 voted in favor. What fraction voted against the proposition? So we're assuming that they voted either for the proposition or against. So if 7 voted in favor, then how many people voted against? That's right, 3. So the numerator has to be the portion expressed. That would be 3. So our answer is 3 out of 10 voted against the proposition. So sometimes you have to do a little subtraction there. Okay, let's do another example. Again, you might want to pause the video read the questions and then answer them, and then click back on play when you're ready to see the answers. Okay, 8 out of 15 students have internet service at home. What fraction of the students have internet service at home? Answer: 8/15. So the top number is the number of students that have internet service, and the bottom number is the total number of students, 15. Okay, B. Laura missed 2 out of 35 questions on an exam. She missed 2. That's how many she got wrong. What fraction? So here's the question. What fraction of the questions did she get correct? So if she missed 2, how many did she get correct? 33, right? So the fraction is going to be 33 out of 35. Okay, let's move on. Fractions are also used to indicate division. A over B is equal to A divided by B. Simplify 40 over 5. Well, that means 40 divided by 5. And we'll do the division here. The second number always goes before the box. Or you can think of it from the fraction. In fraction form, the denominator always is written first in front of the division box. Okay, so 5 goes into 40, it's 8 times, without a remainder, so our answer is 8. So right now we're just using fractions to indicate division. Divide the denominator into the numerator. Here's 2 more. Let's go ahead and perform the division. 2 into 32, 2 goes into 3 one time. Bring down the next number. 2 goes into 12 6 times. No remainder, so our answer is 16. One more of these, 5 into 35. Our answer is 7. So the fraction of 35 over 5 is equal to 7. It simplifies to be 7. Here's another problem. 15 over 15. Well, how many times does 15 go into 15? Once. That's right. Well, actually, any fraction with a non-zero denominator that is equal to its numerator is equal to 1. Any number over itself is equal to 1. So 8 over 8 is equal to 1. 245 over 245 is equal to 1. Any fraction with the same numerator and denominator is equal to 1. I don't think that sentence was quite clear right there. It has to have a non-zero denominator, but that are equal to the numerator. When the denominator and denominator are equal, it's equal to 1. Okay, let's move on. How about a fraction where 0 is in the numerator, also called the dividend, but not the divisor? We'll talk about that later. The answer is always 0. So whenever the top number or the numerator is 0, the answer is 0. So let's go ahead and check that division. 12 goes into 0 how many times? Yeah, 0. Okay, so it kind of worked out. So the answer is 0. So anytime the numerator is 0, the answer will always be 0. So 0 over 8 is 0. 0 over 15 is 0. Remember, the denominator is not 0. We'll talk about that next. Okay, here we go. Division by 0 is not possible. If the divisor is 0, that's the bottom number, the correct answer is undefined. Okay, sometimes people try to say the answer is 0. So let's go ahead and put a 0 there. Now it's wrong, but we're just doing it anyways. Well, 0 times 0 is 0, and then we still have a remainder of 12. So we didn't make any progress. Also remember, let's look at this example that I wrote there. 12 divided by 3 is 4. If you multiply the last two numbers, you have to get the number that we started with, right? So 3 times 4 is 12. That means that answer is correct. Look at the second problem, 12 divided by 0. If you put 0, if you multiply those two zeros, do you get the first number? If you multiply the divisor and the quotient, do you get the dividend? No. So 12 divided by 0 is not 0. I'll cross that out. Anytime the denominator is 0, you must write the word undefined. Not 0, but undefined. Okay, so anytime you see an example or a problem where you have 8 over 0, or 33 over 0, or any number over 0, the answer is undefined. Now, what if they're both 0? Then we say that the answer is indeterminate. Indeterminate. Okay, let's try to think about that for a second. 0 divided by 0. Let's say you could put any number for the quotient. Let's choose 5. 0 times 5 is 0. Subtract. It works out. Actually, you could put any number there. You could put 12, 172. They'll still work out, so we cannot determine what the answer is. This is a topic that's going to be discussed later in calculus. So right now, this is where we'll leave it. The answer is simply indeterminate. So any fraction with both numerator and denominator equal to 0 is indeterminate. Okay, let's move on. Proper fractions. Proper fraction is a fraction whose numerator is less than the denominator. So the top number has to be smaller than the bottom number. Here are some examples. 2 over 9, or 2/9. 6 over 7, or 6/7. And 11/17. 11/17. These are all proper fractions because the numerator is less than the denominator. Well, there's improper fractions. Yeah, you guessed it. We have improper fractions. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. 8/3. See, the top number is larger than the bottom number. The numerator is greater than the denominator. Or equal to, like that last example, 7/7. 7 over 7. It's an improper fraction because the numerator is equal to the denominator. Okay, mixed numbers. A mixed number is a number with a whole number and a proper fraction. So the first one would be read as 4½ You say and because it's an addition. It really means 4 plus a half. 3 3/5. 90 7/25. Or you could say 90 7/25. So these are all mixed numbers. Note that they have proper fractions. This is also important. A mixed number cannot have an improper fraction. So you could not have 90 25/7. The top number must be smaller than the bottom number. And that'll be a topic that comes up later on when we're adding mixed numbers. Okay. Converting an improper fraction to a mixed number. To change an improper fraction to a mixed number, divide the denominator into the numerator. The quotient is a whole number. The fraction part of the mixed number is written as the remainder over the original denominator. Remember, at any time you might want to pause the video, write down the notes, and then come back when you're ready. Okay, let's go ahead and do this. So we're going to divide the denominator into the numerator. So the bottom number always goes before the division box. So 4 into 9 goes twice. 4 times 2 is 8. Subtract to get 1. Okay, so we divided. Now the quotient, which one is the quotient? The 2. The quotient is a whole number, so that's the number that is going to go in front of the fraction. The fraction is the remainder over the original denominator. What number is the remainder? 1. And our original denominator is 4. So our answer is 2 1/4. 2 1/4. 1/4. Okay, let's do some more problems. (29/3). Convert 29/3 to a mixed number. You might want to pause and then go ahead and work these out. Okay, let's divide the denominator into the numerator. 3 into 9. Sorry, 3 goes into 29 9 times. 3 times 9 is 27. Our remainder is 2. The denominator always stays the same, so our answer is 9 2/3. (37/5). Same thing, divide 5 into 37. So the answer will be 7 2/5. So the denominator of the fraction is always the number that we're dividing by, the 5. So 7 2/5. Okay, now let's go the other way around. Converting a mixed number to an improper fraction. The previous problems that we just did, it kind of made sense why we had to change improper fractions to mixed numbers. You wouldn't want to answer a question in the improper form. You wouldn't want to say, oh, it takes 29/3 hours to drive to a location. 29/3, what does that mean? But if you gave the answer in a fraction form, then that makes more sense. So if you said, oh, it takes 9 2/3 hours to get to a location, that makes sense. 9 2/3 hours, that's almost 10. Or in this case, 7 2/3, that makes sense of what that means. 7 2/3 means 7 hours and 2/3 of an hour. Okay, so this section we're converting mixed numbers to improper. Why are we doing that? Well, later on when we're multiplying with mixed numbers or dividing with mixed numbers, it's going to be part of a process to that topic. So sometimes it's hard to see why we're doing something, but it all works out. Okay, to change a mixed number into an improper fraction, multiply the denominator by the whole number, and then add the product to the numerator. This sum becomes the numerator of the improper fraction, and the denominator of the improper fraction is the same as the denominator from the mixed number. Well, that was quite a few words. So we're going to multiply. Just remember, multiply and add, and the denominator stays the same. Multiply. So multiply the 7 and the 3, and then add the 2, and then the denominator stays the same. So 7 times 3 is 21, and then 21 plus 2 is 23, and then the denominator stays the same. Okay, so multiply whole number and denominator, add the numerator, and then write that result over the original denominator. Let's try another one. 9 2/5. So multiply the 9 times 5, which is 45. Add 2, which is 47. That becomes your new numerator, and the denominator, that's right, stays the same. So 47/5. Multiply and then add. Multiply 9 times 5 and then add 2. 13 1/2. Multiply the 13 and 2 and then add 1. 13 times 2 is 26. 26 plus 1 is 27. And I keep the denominator the same. 27 over 2. Okay, I think that was our last problem. It was. So I'll see you here for the next lesson. Have a good day.